Hello students, in previous lecture of metric spaces, I have defined the concept of metric space and various examples on matrix. Today we are going to discuss important topic from metric space, which is nothing but the open sphere. With help of open sphere we are going to define open set, which is a very important concept in analysis, and for that purpose our aim is to study concept of open sphere. But before that, I got one one question from one viewers. I like to explain it firstly. So in some example, I explain the example of metric D from if R x is equal to R minus 0. Okay. X is equal to R minus 0 for xy belongs to x. I have defined d of xy is equal to mod of 1 by x minus 1 upon y. Then D is metric for x, which is set of non-zero real number. So I think you may got problem about showing how it is a metric. So solution. So M1 axiom d of xy is equal to mod of 1 by x minus 1 by y. Whatever x and y real numbers, non-zero real number, for that 1 by x and 1 by y are non-zero real number, this is greater equal 0. Since 1 by x comma 1 by y belongs to r plus r minus 0. M2 d of xx for x belongs to x not equal to 0. Therefore d of xx is equal to mod of 1 by x minus 1 by x, which is 0. For x not equal to y, in x, xy are non-zero, and therefore d of xy equal to mod of 1 by x minus 1 by y. That are real number. This is strictly greater than 0. So from this, d of xy is 0 if and only x is equal to y. M3 d of xy for xy belongs to x, which is r minus 0 set, means x and y are non-zero real numbers. D of xy is equal to mod of 1 by x minus 1 by y, but these are real numbers. Mod a minus b is same as mod of b minus a, so this is mod of 1 by y minus 1 by x, which is nothing but d of yx. So symmetry axiom hold. M4 for xyz belongs to x equal to r minus 0. All numbers are non-zero. D of xz equal to, or xy is equal to mod of 1 by x minus 1 by y. I have to relate with d of xz plus d of zy, so I will insert here 1 by z and add and subtract. So we will get 1 by x minus 1 by z plus 1 by z minus 1 plus 1 by z minus 1 by y. Then mod a plus b less equal mod a plus mod b, this is less equal mod of 1 by x minus 1 by z plus mod of 1 by z minus 1 by y, which is same as d of xz plus d of zy. So thus xd is metric space. Is it clear? So somebody have problem with this, so that's why I explained this example, and it is also revision for all examples of metric. Now our aim is to define open sphere. Closed spheres will define open closed spheres. So definition. Let XD be metric space. XD be metric space. This is abbreviation for metric space. According to me, don't use m.s for metric space. Always write metric space word completely. Then for x belongs to x and r greater than 0, decide SRX. Sometimes I can use SRX D also here. What is this set? It is set of those y belongs to x such that d of yx is less than r. It's called as, it is set of all points in x which are at a distance less than r from x. Okay, it is called as open sphere centered at x or with center x and radius r. Radius r. So you are familiar with circle with center and radius greater than 0. So on the same line, we are defining open sphere here, but it is interior part of that one. Okay. So example, in Ru, for x belongs to r and r greater than 0, what is SRX? It is set of y belongs to x such that d of yx is less than r. Now d of yx is equal to mod of y minus x is less than r if and only if mod of x minus a less than delta implies x belongs to a minus delta to a plus delta, means, or if and only if minus r is less than y by y minus x is less than r. If and only if by adding x we will get x minus r is less than y less than x plus r. This implies SRX is precisely x minus r to x plus r is open interval with center x and radius r. So what is open sphere? Open sphere is nothing but this one. Okay. So thus, from this, every open sphere in Ru is open interval. Note, open interval in Ru may not be open sphere. For example, open ray for A belongs to R, open ray A infinity minus infinity to A and R is equal to minus infinity to infinity. These are open intervals but not open spheres. Not open spheres. Okay. Every open sphere in Ru with usual metric defined on R is always open interval, but open interval, this is node 1 and node 2. Open interval in RU may not be open interval. Example, open ray A infinity minus infinity to A and whole set R is equal to minus infinity to infinity is open interval but not open sphere. Is it clear? Now, next example. Next example. Let XD be metric space. XD be discrete metric space. Discrete metric space with D of xy is 0 for x equal to y and 1 for x not equal to y. Then for x belongs to x and r greater than 0, open sphere SRX is equal to y belongs to x such that d of yx less than r. This is equal to, now if r is 1/2, if I take r equal to 1/2, then d of yx less than half takes only distance 0, so x and y must coincide, y equal to x, which is true for r equal to 0.1, 0.2, 0.999. In fact, if I take r equal to 1 also, r equal to 1, then SRX takes only single point, so it is just x for r less equal 1. And if I take r greater than 1, if my choice of r is 1.1, 2, 3, 3.1, then for that d of xy less than 1.1 means d of xy takes 0 value as well as 1, means for any 2 points in x, distance between them is either 0 or 1, which is less than that r greater than 1, so it is whole set x for r greater than 1. For r greater than 1. Is it clear? So this is about the open sphere in XD. Open sphere in XD. Any open sphere in XD is either singleton set or whole set. Okay. So from this, any open sphere in discrete metric space. Discrete metric space is either singleton set or whole metric space. Whole metric space. Okay. Okay. Now, our next important example is nothing but R2. We can visualize open spheres in R2, R3. R2 and R3. I know that it is difficult to observe that sets, but visually we can observe sets on set of real number on xy plane and in R3, three-dimensional space. Okay. So now, next example. In let x is equal to R2. Then for p is equal to x1, x2, q is equal to y1, y2 belongs to R2. D1 of PQ is nothing but, what is our metric? Mod of x1 minus y1 plus mod of x2 minus y2. What is D2 of PQ is usual distance function under root x1 minus y1 square plus x2 minus y2 square. And d infinity of PQ, which I have defined as maximum of mod of x1 minus x2, x1 minus y1, comma x2 minus y2. Now in this we have to find out open spheres. Okay. Then for r is equal to 1 and O is equal to 0, 0, find S1 D1 0, S1 D2 0 and S1 D infinity origin. Center is origin. Center is origin. So S1 D1 0, S1 D1 0 is equal to set of x1 x2 belongs to R2 such that by using this formula mod of x1 minus 0 plus mod of x2 minus 0 is less than 1. What is that said? It is set of those x1 x2 belongs to R2 such that mod x1 plus mod x2 less than 1. So I am drawing open sphere about origin with radius 1 with D1 metric. Now what is this set? It is set of x1 x2 belongs to R2 such that if I take x1 and x2 are positive numbers, then I will get this to be x1 plus x2 less than 1, where x1 x2 are greater than 0. Union x1 x2 belongs to R2 such that x1 minus x2 less than 1, where x1 is positive, x2 negative. x2 is negative. Then union x1 x2 belongs to R2 such that minus x1 plus x2 less than 1, x1 less than 0, x2 greater equal 0. Union set of x1 x2 belongs to R2 such that minus x1 minus x2 less equal 1, where x1 x2 both are negative. Now we'll plot this. This is my x1 axis, this is my x2 axis, this is origin. See first x1 plus x2 less than 1. If I compare x1 plus x2 is equal to 1, then it is equation of line in two variables x1 and x2 whose x1 intercept is 1, x1 intercept is 1 and x2 intercept is also 1, So for x1 plus x2 line I will get its equation to be, but it is not exactly 1. x1 plus x2 equal to 1 represent this line segment. x1 x2 are greater than 0 in first quadrant. x1 x2 are greater equal 0. Now any line divide plane into two half planes, origin side half plane and non-origin side half plane. So this line also divide plane into two parts, origin side and non-origin side. So if I put origin here 0, 0 plus 0 less than 1 means origin satisfies this inequality. So if one point on that side satisfies that inequality, then all points on that side satisfy that inequality. So for x1 plus x2 is equal to 1, all points on this side satisfies this inequality. x1 and x2 are positive. Similarly, we will do for second one, x1 positive, x2 negative. So it is nothing but fourth quadrant. What is x1 intercept? 1 and x2 intercept is minus 1. So that line is nothing but this. So this is your x1 minus x2 is equal to 1. Again, origin 0, 0 satisfies this inequality. So every point on that satisfies that inequality. This is part for this one. Minus x1. x1 is negative, x2 is positive, means in third quadrant. Here it is a minus 1. Then its x1 intercept is minus 1. x2 intercept is 1. So I will get this line. I will get this line. Again 0 satisfies this inequality. Origin satisfies this inequality. So this side region. This side region. For this, x1 is minus 1 intercept, x2 is minus 1 intercept. Both intercepts are negative. So I will get this line segment connecting minus x1, minus x2 is equal to 1 line, and x1, x2 less than zeros. Means this quadrant. And again, origin satisfies that. So I will get this part. I will get this part here. So this is your, the shaded portion is nothing but S1 D1 at origin. S1 D1 at origin. Is it clear? So even though I have defined this open sphere with center origin with radius 1, you can take any center, any radius, doesn't matter. But when they do such type of calculations, if I have some AB center, if I take radius to be now R is greater than 1, then this just get enlarged. This region just gets enlarged by that 2 means unit. So S2 will become such type of square. S3, that type of square, and so on. If I take center origin to be say 1, 1, then this region just gets shifted to here, whose center will become 1, 1 here. If I take AB to be somewhere here, I will just shift that center of original xy plane, x1, x2 plane to that AB, and without rotating the axis, this unit sphere just get replaced here, and I will get it is to be open sphere about AB with radius 1. Is it clear? And that's why I have just plotted open sphere at with center origin and radius 1. If radius less than 1, then it gets shrink. It will be shrinked. Is it right? Magnification and so on. Okay. So this is about the open sphere in this. Now, if I have to compute here D2, if I take D2, then observe on same line again, S1 D2 0. It is set of x1 x2 belongs to R2 such that D2 of PQ is under root of x1 minus 0 square, okay, or 0 minus that, right, 0 minus x1 square plus, doesn't matter, okay, x1 minus 0 square plus x2 minus 0 square is less than 1, which is equal to set of x1 x2 belongs to R2 such that by squaring we will get x1 square plus x2 square less than 1. Now we know that if I take the equality, okay, x1 square plus x2 square is standard unit circle. Standard unit circle is equal to 1. So standard unit circle. So this is your 1 0, this is 0 1, this is minus 1 0, and this is nothing but 0 minus 1, and boundary is not there. This is origin, boundary is not there, so this is the interior part. This is your S2 1 0. S2 1 0. Now what about the next metric? D infinity PQ. D infinity PQ. S1 D infinity 0. Origin instead of x1 x2 belongs to R2 such that maximize of mod of x1 minus 0 means mod x1 comma mod x2 is less than 1. But what is it? Belongs to R2 such that mod x1 is nothing but plus minus x1 plus minus x2 less than 1. Now if I compare this is your x1 axis, this is x2 axis. If I compare x1 is equal to 1, then this is my x1 is equal to 1 line. X1 is equal to 1. X1 less than 1 means this part. This is my x1 is equal to minus 1 line. And minus x1 less than 1 means x1 is greater than minus 1. So this part. Then this is say 1. x2 is equal to 1. x2 less than minus 1. This is x2 is equal to minus 1. And on this side it is greater than this. So this interior part this is your S1 D infinity at 0. This is open sphere about this. Now if I observe this, I will get this part here. Okay, so this is your S1 D infinity at 0, and this part is for S1 D1 0, and this circle part is for S21 0. So you can observe, okay, from diagram S1 D1 0 is proper subset of S1 D2. S1 D2 0 is subset of S infinity at 0, which is also proper subset. Is it clear? So with this discussion, today we will stop our topic here. By next lecture, I will talk on topic closed sphere, and with help of open sphere, we are going to talk about the open set concept. Bye bye.